Hello and welcome once again to Chalkboard, where maths is taught the easy way. This is a Watch TV, and today we are looking at rational functions. Now, before we start, I'll urge and plead with you guys that you should subscribe to the channel because I have a lot of things for you, and also for better understanding, for the sake of understanding, try to watch to the end so that you get a better understanding of what I'm doing. And I thank you guys too for your comments and your likes and your shares. People are enjoying the class day in and day out. What are rational functions? They are functions that comes in the forms of it comes in the denominator and the numerator like a fraction, right? But either the numerator or the denominator is a function on its own, and mostly they are called polynomials. So that are rational functions. Now, if I say functions on its own, if a number is written as 2/4, this is a fraction. But what I'm talking about, we will see something like this: x plus 1 over x squared minus 1. This is a fraction, and each is a function on its own. So this is what I'm talking about. So this is what we will be talking about. Now, as we know, for fractions we have proper and improper fractions. Now, so if we have 2/3, we call this a proper fraction, and if we have 10/4, we call it an improper fraction. Now, why do we call it an improper fraction, or why do we call it a proper fraction? Now, the example I give under this is that if you have a junior brother and you carry you tell your junior brother to carry you, and you go to town. So your junior brother has carried you the big brother or the big sister. Your junior brother has carried you and gone to town. What will people say? People will say, what are they doing? What is this lady doing? It means that if the big number carries, if the small number carries the big number, it is not normal, right? Because people will talk about it. If the small number carries the big number, it's not normal. So that is the improper. But if the big number carries a small number, that one is normal. So that one we call it what? Proper. So that's the difference between proper and proper fractions. That is all. Now, in the same way, we have improper and proper functions as far as the functions, rational functions are concerned. So if we have a function like this, so x plus 1 over x plus, let's say, 2. Now, these two, if one should be a proper fraction or the other to be an improper fraction, it depends on the degree that will be given to it. So if I put x squared here, it means that the top one is bigger than the down one. So that makes it what? Improper. You understand? So if I have another one to like this, and I have it down here, let's say, let me use 3. If I have another one down here, and let me make the degree 3, because this degree is bigger than this degree of invisible 1. This one is what? A proper fraction. As far as the rational functions are concerned, this one becomes what? A proper fraction. That's what it means. So we look at the degree of the function to determine whether it's a proper one or an improper one. Now, so let's look at the domain of rational functions. Now, someone will say, if we say the domain of rational functions, what does it mean? Now, it simply means that they are all real numbers, including the one that will make the denominator tend to 0. Are we good? It's all real numbers, unless the one that will make it 0. So let's take an example on that. So we have x squared plus 2x minus 8, all on x minus 1 bracket and s plus 1, s plus 3. Now with this example, we want the one that will make this one to 0. So after we know the one that will make this equation or this statement undefined, then we will say that they are all real numbers except the one that will make it undefined. So what we do, we will equate this one to 0 and we equate this one to 0. So we will get x minus 1 equals 0, and also x plus 3 equal to 0. Then this one will give me x equal to 1, and this will also give me x equal to negative 3. Now, if I put 1 over here, this side will be 0. If I put this one also to be here, this one will be 0. And to make this equation undefined, Are we good? So what we say is that the domain of f, that's the function we are talking about, is x such that x is for all real numbers except x not being equal to 1, and also x not being equal to what? -3. Because if I put this -3 here, everything will be undefined. Are you good? So these two, they are all, if you put any other number apart from these two, it will make the statement hold, the math question hold. But if I put negative, if I put 1 here, it will be 1 minus 1, that will be 0. 0 times this also will give you 0, and it will be the numerator over 0, and that is undefined. You understand? So these two make this undefined. So that is the domain. That is the domain. Okay, so now let's look at how to find the range of a rational function. Now, so if we say a range, what is a range? They are saying that the range is the value, the range of a function is the value of y, which makes the x defined. So what does it mean? So it means that when a function is given, we just find x. Are you okay? So let's take a function like f of x maps x over 1 minus x. Let's take this for example. We know that f of x is the same as y, right? So let's say let's make f of x is equal to y. Then that will be equal to x over 1 minus what? X. Okay. So now with this one that we have, we will just make x the subject over here. Find x here. Change of subject. This just change of subject, making x the subject over here. So what do we get? We will get y bracket 1 minus x, like that. Are we good? Equal to x. Then we're gonna get y minus yx equal to x. We are going to get this. Now we are making x the subject, so we have to group the one that has x. Okay, we have to group the ones that has x in it. So we can send this one to this side. So we are going to get y equal to x plus yx, like that. Are we good? Then from there we factorize the x out here. So we're going to get y equal to x bracket 1 plus y brackets close. We are making x the subject. Let's not forget. So what do? We divide both sides by 1 plus y. We are going to get y over 1 plus y being equal to what? X. So that is what we are getting for x. Okay, so x is what? X is y over 1 plus y. So now after we find x, we can see clearly that the denominator here we have 1 plus y. If we use any number for the y, it will hold the fraction, right? But unless -1, if we put -1 here, the down will be 0. You understand? So the -1 will be out of the range that we are about to talk about. If not that, we can't get the range. So it is simply that the range for this this function f is all real numbers except -1. All real numbers except negative, because if we put any other number here, we will get something. If we put -7 here, we will get something. If we put 5 here, we will get something. But if we put -1 here, it will be 1 minus 1, and that will be 0. Then we get y over 0, or another -1 over 0. And -1 over 0 doesn't hold. So the range for f is y is such that it belongs to all real numbers. Y belongs to all real numbers except -1. That is the range. So we write it like this: y is such that y belongs to all real numbers except -1. So that's how you put it. Okay, now let's look at operations on rational functions. Now with this one, we are using the idea of fractions to find to simplify. Now we'll take about 2 or 4 examples, then we move to the different step. Okay, so if we have 1 over x minus 1, then adding up to 1 over x plus 1. Now how do we go about this? Now with this one, we'll just find the LCM of these two. Now someone will ask, we have x minus 1 and x plus 1. How can we find LCM? We can find LCM the same way if we are having 2 over 7 plus, let's say, 1 over 4. We can find LCM. We can also find LCM of this. If we want the LCM of this, we can just multiply the denominators and that will be our LCM, right? So this one too, we'll find the LCM the same way we multiply this and this. We could have even write it like this: 7 and 4. The bracket here means they have multiplied, so we can write it like this and solve it, and we'll get the same answer. Are we good? The same way we'll do this one. With this one, we wouldn't get we wouldn't multiply the 2. That would be a long process. So we'll just write the first denominator and the second denominator, then we'll just solve it, then we'll get our answer. So with this one, what we'll do, we will get x minus 1 in one bracket, then x plus 1 also in one bracket. So that's our LCM. Now this one will go into this times x plus 1 times x minus 1 will go into the denominator this times, and this one will also go into the denominator this time. So it means that when you are finding the denominator for when you are solving this x minus 1, it will go inside this times. You understand? So this also times this will give you one bracket x plus 1. Okay, and this one also go into this one this time. So we are going to get plus 1 bracket x minus 1, like that. Then what do? We will just simplify. So when we simplify that, we are going to get x plus 1 bracket close, another x. Sorry, we are going to get x plus 1 bracket close plus another x plus 1 bracket close, all over. Now the denominator, we can simplify the denominator. How? We are multiplying 2 brackets, so we can simplify the denominator. Are we good? Good. So we can simplify the denominator, or better still, even the numerator, we can still work on it. So what we are doing is, let's still maintain our x plus 1. Sorry, x minus 1 and also x plus 1. Let's maintain our 1 over here. This is what we had. So now let's open. If I open this bracket, I'm going to get x plus 1 plus x plus 1. We are going to get this. So now getting this now, all over x minus 1 in the bracket, then also x plus 1 also in the bracket. So when we simplify that, we're going to get 2x plus 2 all over 2x plus 2 all over x minus 1 and also x plus 1. Are we good? I did not want to cut everything. I want to go step by step so that we understand it clearly. That's why from here I went back to start again. So now after we have this, now the top one, we can do something to we can bring out the 2. We can factorize the 2 out from the numerator. So if we bring 2 out, it will leave with x plus 1 over here, all over x minus 1 and also x plus 1. Are we good? But mind you, this one can take away this one. So we're going to get what? 2 over x minus 1 as our final answer. So that's simplification. When we are asked to simplify this is what we get. This is what we get. Let's take another example on this one. So let's take 4 over x plus 2 plus 3 over x plus 3. So let's take this and simplify. After this, we will take one that involves subtraction. Then we also solve one of them. Then we move to the next one. Okay, so what do we do from here? What we are doing from here is we are finding the LCM as we did over here. So what will be the LCM? The LCM will be x plus 2 and that of x plus 3 again. So our LCM will go equal to x plus 2 in the bracket and also x plus 3 also in the bracket. Now our sign plus will be in the middle here waiting for us. So this one will go into this times. This time this will give me 4 bracket x plus 3 And this one, the x plus 3 will go into this x plus 2 times. So x plus 2 times this will give me 3 multiplying x plus 2. Are we good? Now, we are working with the numerator. So we are getting 4x plus 12 plus 3x plus 6. Are we good? All over x plus 2 in a bracket and also x plus 3 in a bracket. Now let's continue. Now let's simplify the top. This plus this will give me 7x. And this plus this will give me 18. So 7x plus 18 all over x plus 2 and also x plus 3. So that is with this one, we can't do anything to the numerator to cancel something out. Unlike the first one, when we got here, we factorized 2 out. Then we canceled this with this and we had this. But this one, there's nothing we can bring out with the 7 and the 18. No. So we leave it like that with the denominator like that. So that's our final answer. Okay, so let's take one of the minus one and look at that one too. Please don't be confused. With this one, we were able to bring the 2 out. So we had what? 2 bracket x plus 1 dividing this. But this one, we can't bring anything out. We can't bring anything out. We can't factorize anything out from the numerator. So we leave it like that. I hope it's clear. Okay, if you have any questions, kindly send it to the number on your screen. Then I'll see to that for you. Okay, so let's pick another question. Let's pick another question, then let's solve it together. So we have 1 over 2 x minus 1 bracket close plus 2 over 3 bracket s plus 4. S plus 4. Now we have to solve this one. We have to simplify. Now, before we even start, we have to look at the denominators. The denominator of both terms can be what? Simplified before we even look at the general thing altogether. So we can multiply through here, multiply this through, so that we will not have any bracket over here, so that it will be simple. So we will get 1 over 2x minus 2 for the first one. Then our plus sign will come. Then we'll get 2 over 3x plus 12 for the second one. Now we have a simple equation. So what do we have to do? We have to find the LCM. So our LCM here, our LCM will be 2x minus 2 in one bracket, and also 3x plus 12 in also another bracket. So this one goes into this times. This time this will give me 1 bracket 3x plus 12 bracket close. Then this one will go to this time. We're going to get plus 2 bracket 2x minus 2 bracket close. Now we are simplifying the top, the numerator. So we are going to get 3x. This time this will give me 3. This time this will give me 12 plus 12 plus 4x. Please go with me. Minus 4, because plus times minus will give you minus, right? Good. So plus and minus will give you minus. So that's why we had minus over there. So we get minus 4 over there. So now let's continue. Okay, so now over the denominator, 2x minus 2 in one bracket, and also 3x plus 12 in also another bracket. So now what do? We have to simplify the top again. We have to bring the like terms together. So this and this will give me 7x. Then 12 minus 4. 12 minus 4 will give me 8. So that will be what? Plus 8. Then all over the denominator again. 2x minus 2 in one bracket, and also 3x plus 12 in also another bracket. Now with this one, we can't do anything to it again, because the numerator again here cannot be factorized. It's just like the one that we did. 7s plus 18. You can't do anything to it. 7x plus 8. You can't factorize anything out. But in a case where we can factorize, we will factorize like the first one that we did. You see, with this one, we had 2 here, we had 2 here. So we factorized the 2 out and was left with what? X plus 1. Then we were able to cancel. So in the stage where we are, we can factorize, but 7 and 8, we can't factorize anything out. So we leave it like that over the denominator. So now let's look at multiplication and division of rational functions. Now, the multiplication and division is also the same as the fraction that we know. The fractions that we know. When we are multiplying the fraction, we call something top by top, down by down, right? Yeah, that's it. The same thing that we're about to do over here. And when we are dividing, we reciprocate the term on the right hand side, then we multiply. That's the same thing that we do. So let's pick 2 examples over here and let's work with that and let's see. So we are picking they have given us j of x and we have given it f of x. So we have to multiply. So we have f of x being equal to x over x squared minus 1, and also j of x also 2x over 1 plus x. So we are given f of x and g of x, and we are told to multiply f of x and g of x. So we are going to get f of x dot g of x. That will be what? X over x squared minus 1 dot 2x over 1 plus x. So multiply. We know that when we are multiplying, the dots there means multiplication. So the top by top and the down by down. So this multiplied by this and this multiplied by that. We are going to get 2x squared over. Now we are multiplying this. So this time this will give me s squared. This time this will give me plus s cubed. This time this will give me minus 1. This time this will give me minus x. So this is what we are getting. So we rewriting this, we are going to get 2s squared over s cubed plus s squared minus x minus 1 as our final answer. We can't do anything to this again. We just leave it like that. So that's how it is done. The same way, if we were told to divide, we would have reciprocated this one, then change the sign to multiplication, then multiply the top and also multiply the down. So let's take one question that we are to reciprocate. That's the division. So we have 1 over s squared minus 9 divided by 1 over x plus 3. So we have this to simplify. Now, because it's a division, so you see when we are solving maths and we come across 1 over 3 divided by 4 over 6, what do? We reciprocate this one. So we are going to get 1 over 3 times 6 over 4, right? Then we multiply top by top and down by down. So we are going to get 6 over 12. Then we cancel. You understand? The cancellation is not a problem that it's not an issue now. I want you to know that we reciprocate this one. So the same thing that we will do over here. When after we reciprocate this one, then the sign will change to what? Multiplication. Are we good? So let's do the same thing over here. So we are having 1 over s squared minus 9 times, when we reciprocate this, we are going to get x plus 3 on 1. Now it has changed the multiplication. So what do? We multiply the tops and multiply the downs. So we multiply this by this, we are going to get x plus 3. And multiply this by this 2, we are going to get s squared minus 9. Now I'll ask a question. Are we done? Is this the final answer? If we look at the denominator, it means this is not the final answer. Because here we are dealing with difference of 2 squares down there. So this one can be written in a different way, the denominator. If I write it in a difference of 2 squares, I've not done anything. I'm just writing it in a different way. So we are going to get x plus 3 all over x minus 3 and also x plus 3. This is difference of 2 squares. This and this are the same, just that I've written it in a different way. So what do we do from there? Now the denominator has someone here, the same thing, so we can cancel out. So we can cancel this denominator with this. Then here we're left with 1. We are going to get 1 over x minus 3 as our final answer. Please don't be confused from here. You see, after we reciprocated, we multiply the top. We had this. The down also gave us this. But the down here is difference of 2 squares because of the s square and the minus here. And 9 2 can be broken to 3 and 3. So it will be x plus 3 and x minus 3 for this one. That's why we came to we had it over here. Then we cancelled this and this. Then we left with 1 over here. So we had 1 over this one as our final answer. Okay. So thank you very much for joining me up till now. Now we are looking at partial fractions now. That's the under the rational functions. Okay, this is partial. Now with this one, with the idea that we have over there, we are bringing those ideas over here to understand the partial fractions. Now under partial fraction, we have type 1, we have type 2, we have type 3, and also have type 4. So we'll take it one after the other. Then we will look at it. Now, remember, with the beginning of the lesson, I talked about proper and improper functions. As far as the rational functions are concerned, we will make use of this a little bit over here. So let's try and recap that one. Okay, so let's look at let's start with type 1. I don't want to talk much about introduction to make it seem it's too difficult. So let's look at the type 1. Now, with the type 1, the denominator is always a linear equation. If I say a linear equation, what does it mean? What I mean is x plus 3, x plus 4, x plus 5, x plus, you see, it's simple. It doesn't have a degree. Okay? So, and always the fraction is a proper fractions. Okay, it means that the denominator is bigger than the numerator. That's for the type 1. Now, the type 1, we know that when we are solving partial fractions, we split the fractions into 2. Okay, with a and b. Then we solve for a, we solve for b, then we get our final answer. Type 1, let's pick a question. Let's say 6 over x plus 3 and also x minus 3. Now we can see that with this one, the denominator is a constant. And also the numerator, we have x plus 3 and x minus 3. We are using partial fractions to solve this. Now, with this one, we can, because partial fractions, we first we split the denominators, okay? Then we use a and b. That's for the type 1. For we use a and b for the numerator. So we will get like a over one of this one, the first one, that is x plus 3 plus, okay, b over x minus 3. So this is what we will get. Okay, for the type 1, always a and b, then we'll split the numerator like this, then we just go. Now from there, what do? We find the, we were finding them when we were doing simplification. We were finding the LCM, then that's what we're about to do over here. So what we've done so far, we are bringing some of the ideas to this one. So we are about to find the LCM and also use fractions, how to find LCM with the fractions and also simplify. So what do? We find the LCM of this. And the LCM of this is this and that. So we're going to get x plus 3 here and also x minus 3 here. That is the LCM. So let's break it down. So this one goes here this times. This one goes into this times. So we are going to get a multiplying x minus 3, brackets close. And this one, the denominator here also goes here this time. So we're going to get plus b, bracket, x plus 3. Are we good? Are we good? I hope it's clear. Please, I want you to understand. That's why I'm taking my time. So now, do we know that the LCM here is what? This and that. Okay? This and that. Now what do we do again? Now, since the denominators are the same on each side, then what we have to take the numerator. We have to take the numerator and equate the numerator to this one. Then find the value of a and b. After we're done, then we'll come back pick the this one, then we'll mount the a and b values on it, then we are done. Just simple like that. Okay, so now we are going to get 6, that's the numerator over here, being equal to a bracket x minus 3 plus b bracket x plus 3. You are going to get this. So now from here no, we are finding the value of x, the 2x. So we will equate this one to 0 and equate that one to 0. So we are going to get x minus 3. Then we are going to get 3. We are going to get another one, x plus 3. We are going to get negative what? 3. We are going to get x equals 3 and x equals what? Minus 3. So now we are putting the x equals 3 inside these equations and see what we will get. Now for here there is no letter over here, so we leave it like that. So this is what we are going to get. Now for the first one, this is what we are getting. So for x minus 3, we are going to get 6, because if there was to be a variable here x, we will put in the x there again. After we will take a question that involves that x, so that we'll see how it will be. So we're going to get 6 being equal to, now this x, this one is from here, right? This one is from here. So we'll put this 3 into this one. So 3 plus 3 will give you what? 6. Then we get what? 6b. We get 6b. Are we good? Then we are going to get b is equal to 1. Because if you divide here by 6, divide here by 6, you're going to get b equals 1, right? Then the next one to for s equals minus 3, the 6 will come again, because the 6, there's no letter to it that we can. Now that one is from this one. B is from this one, right? The second one is from this one. So we'll put the minus 3 inside this one. So if we put minus 3 here, we are going to get minus 3 minus 6. And that will give it to us minus 6a equals minus 6a. Now if we divide this one, we are going to get a equal to minus what? 1. So we are getting a equals minus 1. And we are getting a equals what? Minus what? A equals 1, b equals 1, and a equal to minus 1. Now what do? We know this one over here, so we just put them on top of it, and that's all. We put this one on top of it, and that's all. So we know that we already know that a is equal to x plus 3 plus b is equal to x minus what? 3. So we put them. A is minus 1. We are going to get minus 1 over x plus 3. And also 1 equal to x minus 3. That's our final answer. That's our final answer. That's our final answer. Now, I know people will be getting it a little bit difficult somewhere and somewhat. So what we'll do is, let's take another example. Okay. For the simplification, for the factorization that we had this one, someone wouldn't understand, so let me do it a little bit small over here. Okay, let me do the factorization over here. So we have x squared plus x minus 2. Now what do? When we are factorizing something like this, what do? We say that we pick the coefficient of the x squared, multiply it with this one, find 2 factors down. When you add up, you get this, but when we multiply, we get the other. So we will get 2, and that we get 2 and minus 1. 2 and minus 1, when you multiply, 2 and what? Minus 1. When you multiply, you get minus 2. But when you add, you get what? 1. So we look for 2 numbers. When you multiply, you get a constant. Okay? 2 numbers, when you multiply, you get a constant. But when you add, you get the middle one. Then you replace it with the middle one over here. So we are going to get x squared plus 2x minus s minus 2. Okay, so this is what we are getting. Then what do? We just group them and factorize. So we bring 2 out here. We are going to get x plus 2 here. Okay, so we are bringing x out. Sorry, we are getting x plus 2 here. Then this one too. You see, we have minus and minus here. So we if we bring minus out, minus 1 out, we are getting x plus 2 here. Okay, so we are finally we are getting x minus 1 in one bracket, and also x plus 2 is also in another bracket. So that's why I use that too. Now the position doesn't matter because they are multiplying. Either you can bring the x minus 1 first or x plus 2 first. It doesn't matter. So that's why I just became this. Okay, now let's continue. So from here we know that we have to split the denominators to a and b. So we will split them here. So we are going to get a over x plus 2 plus b over x minus what? 2. Sorry, x minus 1. X minus 1. Now from there, what do? We find the LCM. We know the LCM is always the two denominators. So we find the LCM here. The LCM is x plus 2 and also x minus what? 1. So this goes here this time. So we're going to get a bracket x minus 1 bracket close plus b goes here this. So we're going to get this bracket s plus 2. Now what do? We pick the numerator, then equate it to the new numerator that we have. So we are going to get 3x plus 2, okay, being equal to a bracket x minus 1 bracket close plus b bracket open s plus 2. So now we have this. So this is where a little bit of confusion comes. So we are finding the value of a and b, then we fix it on top of this one, then that's our final answer. Now mind you, the first one that we did, it was having only 6 here, but this one, it has 3x plus 2. So we'll make use of the x over there when we after finding the x. So we have a bracket x minus 1. Okay, when we find this one, we are going to get x minus 1 equal to 0. Then we get x equal to 1. You understand? That's we got it from the a. Then the other one from the b, we have x plus 2. So we're going to get s plus 2 equals 0. Then we're going to get s equals minus what? 2. Are you good? So now after we have this, we are going to put it back in the equation so that we get what we want. Okay, so now let's do this one. I want us to do it one after the other. Okay, let's do one after the other. I don't want to rush on this one. This place is very, very delicate, so let's listen very, very attentively. Now we'll put this one in this statement we have here. So if we put this one here, that is for x equals 1. That is for this one. We put this one here. So if we put this one, we are going to get 3 plus 2. That is 5, right? So it's equal to 5. I hope it's clear. We put this one over here. So we are going to get 3 times 1 plus 2. That's 5. Okay. So 5 being equal to... Now you can see that this one here, it is from this A. That's why I brought I intentionally brought the A. So you know that it's from the A. So this one is from the A. So the same thing, we will put this one in this one again. So you are going to get 1 plus 2. That's 3. That's 3b. 3b. Please, I hope it is clear. I hope it's clear. So from there, we find b by saying that we divide here by 3 and divide here by 3. So we are going to get b equals to what? 5 on 3. That's for b. Okay. Now let's look at the other one. Now we are putting this one also in this. We are putting this one also in this. Now you see, the A one helped us to find the B. So the B one will also help us to find the what? The A. That's all. So the B one was here. So for x equal to minus 2, we'll put the minus 2 here. So we are going to get 3 bracket minus 2 plus 2. So 3 times minus 2 is what? Minus 6 plus 2 is minus 4. Are we good? So we are going to get minus 4 equal to, now this 2 here, it is from this B. So we'll put this one also in this equation. And this is the A. So if you put it in A, we are going to get minus 2 minus 3. Sorry. We're going to get minus 2 minus 1. And that will give us what? Minus 3. So this will give you equal to, this will be equal to minus 3 a. Then we find a. So we're going to get a being equal to 4 over 3. Why 4 over 3? We divide it by minus 3 and divide it by minus 3. Then this and this will cancel. Then this and this also will cancel. Then we get 4 over 3. Now we have our a and we have our b. What do we have to do next? We have to pick them and put it on top of the equation that we are solving. So this is how we write it. We write the equation. So we have 3x plus 2 over x squared plus x minus 2 is equal to the a. This is the a. So it is 4 over 3 over the a is what? X plus 2. Then plus the b is what? 5 over 3 over x minus 1. That's all. That's your final answer. So now, with this one, when we simplify the down here, when we factorize the down here, we are going to get 11 over minus 3x all over x minus 1 bracket x plus 3. Okay, we are going to get this when we simplify this, like as I did in the second example. I did it at the corner there. We'll get this. So with this one, it can be written as a on x minus 1 plus b on x plus 3. Okay, like this. Now from there, what do? We find the LCM of this fraction. So the LCM of this fraction is what? X minus 1 and also x plus 3. Now this goes here this time. So we're going to get a bracket x plus 3 and also plus b equals x minus 1. You're going to get this. Now from there, what do we have to do? We have to equate the numerator here with the new numerator we have over here. So we are going to get 11 minus 3x being equal to a bracket x plus 3 bracket close plus b bracket x minus 1 bracket close. Okay, so now this is what we are having. Now as we have this, what are we doing? We are finding the value of x in both this and this. So we equate each of them to 0. So if we equate this one to 0, we're going to get x plus 3 equal to 0 and x equal to what? Minus what? 3. Then this one to x minus 1 equal to 0. We're going to get x equals what? 1. Now this x equals 0 is from the a, the one that has a to it, right? So we'll put it in this one and this one. Okay, so for s equal to minus 3, we are getting, if you put this one here, we are going to get plus 9 plus 11. We are going to get what? We are going to get 20. So we're going to get 20 being equal to, if we put this one here, we are going to get minus 3 minus 4, minus 3 minus 1, that's minus 4. We're going to get minus 4b. Then we solve them, we divide it by minus 4 and divide it by minus 4. We're going to get b equals what? Minus 5. That is for the minus 3. That's this one. Now let's come here. So we have this, we'll put it here. We'll put this one here. Then we're going to get, that is for s equals, so that is for s equals 1. We are going to get, we put this one here, we are going to get 9. When we put this one here, we're going to get 8. Because if you put this one here, we are still getting minus 3. So 11 minus 3 is what? 8. So we're going to get 8 being equal to, if you put this one here, we're going to get 4a. We're going to get 4a. So we divide here by 2 and divide here by 2. We're going to get a being equal to 4. Now we have our a and we also have our b. We have our a and also have our b. So what do we do? Let me just write it here. So we'll put them on it. So we have a over, sorry, we already have a over x minus 1 plus b over x plus 3. So we'll put them on it. So the a is 4. So I'm going to get 4 over x minus 1 plus minus 5 over x plus 3. So that's our final answer. So our final answer, we can quote this one. We can quote the question, then make it is equal to this. So this one is equal to this. That's our final answer. That is our final answer. Okay. Now, to prevent the video from being too much lengthy, we will end at type 2, and our next video will be with the type 3 and the type 4, because type 3 and type 4 has a lot to it. So we will end this video, this section of the rational function, at type 1, and my next video will also be type 3 and type 4. Okay. Now with the type 1, we know that it is in the form a plus b, right? Then here being, let's put something here, x plus 1, maybe x minus 2, right? This is the form, right, of the type 1. Now with the type 2, it comes in a different way. Now with the type 2, we will maintain this one. So type 2, we will maintain the first one, a. Okay, we will maintain the a. Then the b side will go with bx plus c. Also on another one. It's just simple. Okay, it's just simple. So we don't have to worry that much. Now, one more thing you have to know about the type 2 is also that it contains a quadratic factor. Now, one of the factors will still have the square. Okay, that is why we are putting it this way, so that the square part of it will take this one, then the other side will also take this one. Okay, so that's how it is. It's not anything that is difficult. So let's just take it one after the other. Now let's take a question to the type 2, maybe 2 or 3 questions. Then we'll end this section of the rational function. Then the type 3 and 4, we'll do it some other time. Are we good? Okay, so let's look at a question under that. Now let's take 3x plus 1 on x minus 1 and also x squared plus 1 like that. Now with this one, we know that this is still a quadratic, right? This is still a quadratic. This is a factor, but it's a quadratic because of the square we have over there. It's making it a quadratic. So when we are expressing this one, the first one will go with the a. So a over x minus 1. Then we close it. Okay, a equals x minus 1. That's this one. It will come. Then the plus bx plus c will go with the quadratic factor. That is what? S squared plus 1. So that's how we will express it. Then from there, knowing that from there it follows the same step, we'll find the LCM. We will create this one to the new numerator that we have. Then we'll find a, b, and c. Like that. We move like that. So let's continue with this one. So we'll find the LCM over here. So the LCM over here will be what? X minus 1 and also s squared plus 1. Okay. Then this goes to this time. So we're going to get a bracket s squared plus 1 bracket close. Okay. Then b. Then this one. This is the b component. The b component is what? Bx plus c. Okay. So this one multiplying x minus 1 like that. It's nothing difficult. You see, if this side was to be x plus ax, we will bring the ax here because the b component had bx plus c. That's why we brought it here to multiply with this one. So we equate this equation to the new one we have over here. So we are having 3x plus 1 being equal to a bracket s squared plus 1 bracket close plus bx plus c in one bracket and also x minus 1 also in another bracket. So that's how we do it. For s equal to 1, if we put 1 here, we are going to get 3, right? Plus 1 is 4. So we're going to get 4 being equal to. Now if I put 1 here, we get 1 plus 1, that is 2, right? So we are going to get 2a. Then plus, let's put 1 here. If I put 1 here, I'm going to get b plus c, right? Good. Multiplying by 1 again. So 1 minus 1 is 0. So this will make everything here go to 0. So we get plus 0. Then we are going to get 4 over 2 here. Then 2a over 2. Then we're going to get a being equal to 2. Do you get it? So now we have tried 1. So let's try something else. Let's try 0. Okay, let's 1 and let's come to 0. So for s equal to 0. Now if we put 0 here, okay, if we put 0 here, this side will go to 0. So we're going to get 1. We're going to get 1, right? We're going to get 1. Now getting 1 now, let's come here. Being equal to, if I put 1 here, okay, if I put 1 here, I'm going to get 1. Sorry, if I put 0 here, we are working with 0. So if I put 0 here, I'm going to get 0 plus 1. That is 1. So 1 times a will still give us what? A. Right? Now let's come here. Then plus, if I put 0 here, this side will go to 0. That is only c over here. And if I put 1 over here, okay, if I put 1 over here, I'm going to get if I put 0 here, I'm going to get 0 minus 1. That is minus 1. So I'm going to get c times minus 1. So I'm going to get minus c. Let me take this one again. What I'm saying is, if I put 0 here, this side will be 0. Then here the left is c. If I come here, if I put 0 here, I'm going to get minus 1 over here. So I'm going to get c times minus 1. That's minus c. Okay. So now getting this, I know that this can also be written as 1 equals a minus c. But we solved a already here. We solved a already here. And a is equal to what? 2. Okay, a is equal to 2. So therefore, we're going to get 1 minus 2 minus c. 1 equals 2 minus c. So we're going to get 1 minus 2 equal to minus what? C. Then I'm going to get minus 1 equal to c. Minus c. That is c is equal to what? 1. Very good. We're going to get c is equal to 1. Now we have a and we have c. Now we have to find b. Now finding b, you know, always know 2 will be easy to find like this, but the other one, no, you have to simplify. Then after your simplification, you have to group the one with the quadratic before we do factorizing, before we know how to get the what, how to get the b. So now let's see that. Now let's expand with an identity of 1. That's what we can use to factorize, to expand the bracket. So we have 3x plus 1. Then we have, the question is, we have a bracket s squared plus 1 bracket close plus b bracket, sorry, plus b in a bracket s plus c bracket close bracket open x minus 1. So this is what we are working with. Now let's expand. So we are going to get 3x plus 1. Then we are going to get, this one will give you as cube, sorry, as square plus a plus, then this and this will give me bs square minus bx plus cx minus c. So this what we will get. This is what we will get. Now, what do we do from here? After expanding this one, what do? We have to group them. We have to group everything together. So let's group them. So grouping them, you know, the one with the square will come together. Okay, we are grouping the one with the squares. So this and this are the same. So we'll group them. So we are going to get as square plus bx square. Now this for this and that. So let's come to this, minus bx plus cx, then plus a minus c. Okay. Now when I'm bringing the s square out, I'm going to get a plus b in the bracket s square. The s square can come here or here with the factorization. It doesn't matter. Then I'm going to get minus b okay, so it will be like this, then x, because I'm factorizing. If I multiply this, the minus here by this, I'll get this. If I multiply by this, I'll get this. Okay, so here will be minus, so minus times this with the x, I'll get this time that, so I'll get that. Then the last one will give me plus what? A minus c, 0. So we can get 0, we can get a plus b is equal to 0. Okay, now we know that a is what? 2, so we are going to get 2 plus b is equal to 0. Okay, then we are going to get b is equal to what? Minus 2. So now we have our b to be minus 2. Now we have our a, our b, our c. So now what next? Now let's try and write the final answer. So hence our question was 3x plus 1 all on s minus 1 and also s squared plus 1. And this is giving us our a is what? We were given, we got a to be 2. So we are going to get a over, the fraction for a was s minus 1, bracket close, then plus, now our b, we had minus 2. So minus 2x, okay, plus c, we had 1 all over s squared plus 1, bracket close. So that's our final answer. So you see that the b component has come here, and the the c, this is the c component, this is the b component, and this is the a. So the a is what? I think we had 2 in a, so here supposed to be 2. So that is all. That's our final answer. That's our final answer. Okay, so let's take this one. 7s raised to the power 2 plus 5x plus 13 all on, in first bracket s squared plus 2, second bracket s plus 1. So let's solve this one. But you see, with this one, no, they brought the quadratic first just to confuse you. So it means that because they brought the quadratic first, that is the we will write it in a way that the quadratic part of the partial fractions will come first. Okay, it's just the same thing, just that they just changed it. Okay, so let's also do it as they want it. They want us to do it. Now, splitting this one, because the quadratic aspect is first, no, we are going to get ax plus b on s squared plus 2, because that's the quadratic part. Okay, always the as the bs plus c will be on the quadratic part. So now the quadratic part is the first one. That's why you are bringing the as plus b over here. Then plus the c component will have the x plus 1. Like that. If this one was to be here, and this one on the other side, the a will come first on this one, then the other side, the bs plus c will be on this one. So it's the same thing, just that they've changed it just to confuse you. Okay, it's not anything difficult. Just let's move with the flow. Okay, all questions should come to the WhatsApp number you see on your screen. Okay. Okay, now let's continue. What do we do from here? We find the LCM. So what's the LCM? So we find the LCM over here. We have s squared plus 2 in one bracket and also x plus 1 in another bracket. So this goes here this time. So we are going to get ax plus b in a bracket, then x plus 1 also in another, like that. Then plus, this goes here this time. We're going to get c bracket s squared plus 2, like that. So now what do we do from here? We just have to equate this one to the new one. So we're going to get f 7x squared plus 5x plus 13 being equal to ax plus b in a bracket, another bracket, x plus 1 in a bracket, plus c, then s squared plus 2, like that. So now what do? We use the identity. So let's try the identity. We can start with 1, we can start with 0, we can start with -1, any one. So let's start from negative 1, or let's start from 1 coming to negative 1. Okay, so let's start from 1. If I put 1 here, so let's see, if I put 1 here, this side will be 7 plus 5 plus 13. So 12, that will be 25. Okay, so we will get 25 equal to, if I put 1 here, I'm going to get A plus B. Then here will be 2. So I'm going to get 2A plus B. 2 bracket A plus B. Then this side 2, I'm going to get, if I put 1 here, I'm going to get 3C. So it means that all the variables are there if I use 1. AB will be there. Then C2 will be there. You see, but the identity that we want, identity that will make sum go to 0. So that when sum goes to 0, we will solve sum and solve the other later. So let's try 0 and see. So let's put 0 here. If we put 0 here, this will be 0, this will be 0, then we get 13 here. If I put 0 here, this will be 0, but I'll get B here. If I put 0 here, this will be 1, so I'll get 1B. So that's only 1B. Then if I put 0 here, here will be 0, then I'll get 2, so I'll get 2C. So 2C. So this one will help us. Okay, this one will help us. But before that, let's find the one that will be single before we come to the 0. Okay, so now let's use negative 1. Okay, so putting S equals negative 1. If I put negative 1 here, negative 1 square is 1, so we get 7. 7 plus this will give me what? 7 plus this will give me 20. 20 minus 5, because if I put negative 1, I'll get negative 5. That will be 15. So I'm going to get 15, okay, being equal to. Now, if I put negative 1 here, this side will be 0. Then 0 will make all this side to go to 0. So it will be 0 plus. If I put negative 1 here, negative 1 square is 1. So 1 plus 2 is 3. Okay, so I'm going to get 3C. You get it? Now let's, so the simplest is going to get 15 equals 3C. Then C will be, give me what? 5. Okay, now we have C to be 5. Now let's go to the other one. Let's use 0. Now if I put 0 here, everything here will be 0. If I put 0 here, everything here will be 0. Okay, so putting 0, we're going to get only 13 here being equal to. Now if I put 0 here, everything here will be 0. Let it only be here. If I put 0 here, we will let it only 1 here. So I'm going to get B plus. If I put 0 here, here will be 0. Left it 2 plus what? 2C. Okay. Now we know that C is 5 from here. C is 5. So I'm going to get 13 being equal to. 13 being equal to B plus 2, 5. So I'm going to get 13 being equal to B plus 10. So we send it here. We're going to get 13 minus 10 equal to B. Then our B will be equal to what? 3. Okay. Now we have our B and we have our C. Now let's go to the A. The A is what I said we will expand. Okay, we will expand with an identity of 1. So let's do the expansion and see. Let's do the expansion and see. So we have 7x squared. We have 7x squared plus 5x plus 13. Then we also have ax plus b in a bracket, x plus 1 in a bracket, plus c bracket s squared plus 2 bracket close. So we want to expand this one. Okay, so we are expanding this one. We are going to get ax squared plus ax plus bx plus b plus cs squared plus 2c. Okay, this is what we will get when we expand the whole of this. Now we will group them. The one with the the power 2 will come together. Then the x's to go together like that. We'll group them. So we are going to get this and this. So we're going to get ax squared plus c s squared in a bracket like that. Then plus bracket ax plus bx also in a bracket. Then plus 2c plus b also in another bracket. So now this one, let's factorize. So when we are factorizing, we are going to get x squared out, then we're going to get a plus c bracket. With this one, we bring x out, then we're going to get a plus b in a bracket. Then this one will just maintain like that, 2c plus what? B, like that. It's not difficult, just that it's kind of complex, so you have to just follow. Now from here, we have a and c, we have b and c. From here, you see, we have c, we find c, we find b, left with the a. Now there is something here we have to look at. Now after we factorize, okay, after we factorize, we are picking the one with the s square, okay. The one with the s square also has a component over here, that's 7. It has a coefficient of 7. So we are picking the coefficient of the s square here and the s square here. If we are using this one, we are picking the coefficient of this one, this is the coefficient of the x over here, and pick this one, then equate it. If you are using this one, we are picking the coefficient of this and that, then use it. Okay, we get the same answer. Let's try them. Now, first, we are picking the coefficient of the s square here. That's a plus c, that's the coefficient. So we are getting a plus c is equal to 7. Then we know that the 5 is what? The c is 5. So we are going to get a plus 5 is equal to what? 7. Then we are going to get a equals what? 2. We are finding a, right? So let's use this one. Whether we can find, we can still get 2. That's x. We are using the coefficient of the x here. That's 5. So I'm going to get a plus b is equal to what? 5. We know that we know that a here is what? 2. We find a already. Okay, let's assume we don't know a. Okay, let's assume we know a already to be 2. So let's fix and see. We're going to get 2 plus b equal to what? B is equal to 5. We're going to get b is equal to 3. This is a proof that our answer is correct. This is just a proof. Now let's use this one to find c, whether we'll get 5. This, what I'm doing here now, is just a proof to show that what we've got is correct. So we are picking the constant and the constant. So I'm going to get 2c plus b is equal to what? 13. Now we know, let's say we don't know c, but we know b to be 3. So we are going to get 2c plus 3 equals to what? 13. We're going to get 2c equals 13 minus 3. So 2c equals to what? 10. So c is equal to what? 5. That's what we had over here, 5. So it means that all this is what? Correct. This is just a proof that our values we are using is correct. So when after you've solved this one and you want something to, you want what you equate it to, look at the numerator over here. If it has s square component, take the coefficient of the s square and equate it to the coefficient over here. If it doesn't have, it means it is 0. Okay, the same thing. If you want this one, you use the same thing, then you get it. Okay, now what's our final answer then? Our final answer then becomes a is 2, so 2x, b is 3 on s square plus 2 plus c is 5 on x plus 1. That is it. That is all. That is all. It's so simple. It's so simple. It's so simple like that. That is all. Okay, so I want you to try these questions for me. Then you send me the answers to the numbers on your screen. Then I'll take my time and go through and we see if we had it correct. So just 3 questions, probably 4 questions, 2 from the type 1 and 2 from the type 2. Okay, so just 3 questions. So we have s square plus 1 all on s square plus 2 and also x minus 1. Okay, solve using partial fractions. Solve using partial fractions. So this number 1, that's number 2. We have 1 on x bracket s square plus 1. That's another 1, 2. Then also and also we have question 3 to be x plus 1 on 3x squared minus 11x plus 10. Then our number 4 for the day will be 9 over 2x squared plus x. So this is what we have. So kindly do this for me. Kindly try your hands on this 4. Also, this is my number again.